This is lesson 26 for 8th grade, and today we're talking about transformations. And transformations mostly deal with geometry. So today we're talking mostly about geometric processes. And we're just going to jump in and look at the different transformations we're talking about. Main things we want to take away from today, we're going to talk about four different types of transformations: reflection, rotation, translation, and another one called the dilation. We're going to go through all those. And basically we want to be able to decipher between the four. So we want to be able to say, or if we're looking at a picture, we'd be able to identify which translation we're talking about, or which transformation we're talking about, sorry. So between the four, we want to be able to decipher which transformation we're talking about, and we also want to know how to apply these transformations. We won't get into that so much today, but in the future we will, and especially once we get to geometry. So let's look at what these are first of all. It says here, transformations are operations on a geometric figure that alter its position or form. So we're going to take different objects or shapes, and we're going to alter its position or form. Basically that means we're going to move it in some way, and we might even change the form of that shape. So that's what a transformation is. It says these are used for computer graphics and in animation. So a lot of like video games, computer applications, when you're putting together blueprints, stuff like that, has a lot of application in the real world. We're going to consider, like I said, 4 different transformations, and below we're going to illustrate 3 of our main ones. We're going to take triangle ABC, and we're going to move it to its image A prime, B prime, C prime, and that's how we call that. So basically, A prime corresponds to the original A, where it was before we did our transformation. So first one we have here, we have a reflection. And a reflection is basically like a mirror image, and they associate the word flip with that. Basically, you flip it across a line of reflection. So if this was our line of reflection, the mirror image of triangle ABC would be A prime, B prime, C prime. So you can see which ones correspond with each other there. So basically we flipped ABC over the line. Notice that if we were to fold over that line, this triangle and this triangle would overlap perfectly. Okay. Rotation, we're going to associate the word turn with that. Think of a steering wheel. When you turn the steering wheel, it rotates, right? This is no different. So if we rotate this triangle, A, B, C, we get A prime, B prime, C prime. So we just turned it once this way. And it looks like it was turned 90 degrees, which we'll get into. And our last one, a translation, we're going to associate the word slide with that. It doesn't change the position, well it changes the position, but it doesn't flip it or rotate it at all. It's still facing the same direction and all that. All it does is it slides it. You can slide it to the right, you can slide it up. So basically you're going to give it a horizontal slide and or a vertical slide. So you could slide it vertically, you could slide it horizontally, you could do both, and in either direction. So we'll look at those a little more in depth here, but one thing we want to notice that the size of the figure is not changed in any of these transformations. So you still have the same shape. We did not change the size of it at all. Still the same shape, even though it's in a different position. Alright, so a reflection, that's the first one we talked about. It occurs across a line. And it says here we show a reflection of triangle ABC across the y-axis. So here's our line of reflection here. That would be the thing that you would fold if you wanted to overlap these two shapes. A couple things we want to notice here. C and C prime are both 2 units away from our line of reflection. So 1, 2, 1, 2. Alright? And A is 2 units away, as is A prime. So whatever part corresponds with your original shape will also be the same distance away from whatever your line of reflection is. So B is 1, 2, 3, 4, 5 units away. So B prime has to be 5 units away. 1, 2, 3, 4, 5. Okay? And once again, once we fold over this, these two should line up perfectly. Let's see, what's it else say? A segment between corresponding points is perpendicular to the line of reflection. All that means is if we took A and A prime, their corresponding parts, we drew a segment to connect them. That's going to be perpendicular, or at a 90-degree angle, to the line of reflection. And that's the case for all of these. And if we did B and B prime, they're on the same segment as, or the same line as C and C prime. So that's how reflections work. Okay. Now rotation, we talked about that a little bit earlier too. So the positive rotation turns a figure counterclockwise about a point, or around a point. Here we show a 90-degree rotation about point B. So point B is the point of rotation. That, if that's the point of rotation, that point is fixed, it's going to stay there. So B will stay, everything else is going to rotate 90 degrees. So basically you would move your paper, hold your pencil down on a point, move it so that you had a 90-degree turn. We aren't going to be doing this in class. They will do it more so in high school, but we do want them to see and get the idea of what's going on here. So basically B will stay put and we're turning everything else 90 degrees. So we would need some other tools to do that. But we want them to know that if we were to trace our path in any other point during this rotation, we find it sweeps out an arc of 90 degrees. That's what they're showing right here, a 90-degree turn. So you can't do a rotation unless you have a fixed spot to rotate around, and in this case it is B. So mostly we're just going to want to be able to identify what a rotation is. Translation was the other one we talked about. It says that was the one we associated with the word slide. So a translation slides a figure a distance and a direction without flipping or turning. So here we show a translation of 6-1. Kind of looks like a coordinate or a point. Our points, remember, go horizontal direction first and then vertical direction second. So we took each of these, B, C, and A, and we went over 6 in the positive direction and up 1 in the positive direction. So we went 1, 2, 3, 4, 5, 6 for B, and then up 1. And that's where we get B prime from. So each point goes over 6 and up 1. So if we were to show that, C would be the same thing, and so we're there. Alright, so I didn't draw those lines very straight, but they would all be parallel because they're all the same slope basically. Over 6, up 1. Over 6, up 1 for each point. So this describes the horizontal shift. This describes the vertical shift. Translation just slides the shape. Alright. So here they want us to describe which transformations we would use in order to get ABC, triangle ABC, to look like this. Alright. I have all of them. They're going to line up down here, the ones we would have to do in order. We'd have to do multiple transformations to get it to look like this. And I'm going to check my time real quick, sorry. Alright, so first thing we have to do, and they don't have to go in this order, but this is probably the easiest order. First thing, we're going to want to flip this around. Looks like they took and they rotated, no, they didn't rotate it, they reflected triangle ABC, and they did that around this line right here. So on line AC, they reflected it. All that happened was they took this and flipped it around here. Mirror image would be this right here. So that's the first thing they did. Second thing they did, it looks like they probably rotated it. Yep, they did. So they rotated this one. Now we're here. They rotated it, looks like 90 degrees around point C. Point C stayed in the same spot. So that was their point of rotation, so that stayed. Everything else went in that rotation direction, right here, 90 degrees. And the last thing that we would have to do is slide it over. Looks like we'd have to slide it over in the horizontal direction and in the vertical direction. So they took this and they slid it over, let's see, 1, 2, 3, 4, 5, 6, 7, 8, and up 1. So each point went over 8 and up 1. So in order to get this thing to fit over here, we had to use all 3 transformations to do that. Alright, and we did talk about this already a little bit. Excuse me. It says 3 transformations described above, or the ones that we were just talking about. Those would be the rotation, reflection, and translation. They do not change the size of the figure. These transformations are called isometries or congruence transformations because the original figure and its image, the results, are congruent. So you still have the same shape no matter what. It just might look like it's flipped around in a different way. However, we do have one transformation that does change the size of a figure, and it's called a dilation. A dilation is something we've talked about a little bit already. It's a transformation in which the figure grows larger. Think of dilated pupils. When you get your pupils dilated, they get larger. A contraction is a transformation in which the figure grows smaller. So here's an example of a dilation. Take this picture and we make it larger. The picture is the same picture, it's just that it's larger. We blew it up, kind of like zooming in on something. So we still have the same shape, but it's a different size. We would call these things similar. And I know I'm getting close to my time, so I want to check. Alright, we're doing okay. So yes, we would call these similar. They're not congruent, but they are similar. They are in proportion. So I think that's what this talks about. Dilation changes the dimensions of the figure, does not change its shape. The original figure and its image are similar, and corresponding lengths are proportional. Thus, dilations and contractions are similarity transformations. So the previous 3 transformations were congruence transformations because the shapes were still the same, even though they may have been positioned in a different area. These are similarity transformations. The shape is not the same, but they are in proportion with each other. So we can see that right here. If we take this rectangle and we blow it up, we can see that there's a center of dilation point. We won't really get into that, but we can see that we're still going to be in proportion. A to B and A to B will be, if we took this length here and divided it by this length here, it would be the same as taking this length and dividing it by this length. They would be proportional or similar. Same shape, different size. And it says to note that corresponding vertices are on the same rays from the center of dilation, and that the corresponding segments of the triangle ABC and its image are parallel. So they're just saying that this segment is parallel to this one is parallel to this one, and so forth. This might seem a little weird, but I'm going to show you an example here that'll clear this up a little bit. And I think I might have to put this on a part 2, so let me check. This might have to go on part 2. Yep, we're going to go over this example on part 2, so make sure you look at part 2. It won't take long, maybe a couple minutes, and then we'll be done.